Good morning students. I hope you all are good. Today we are going to discuss the lesson laws of motion. I hope you all are studied in our previous class, isn't it? We have discussed so many things: introduction of laws of motion and definition of force and inertia and their types, isn't it? Today we are going to discuss linear momentum. What is the topic? Linear momentum. That represents by the symbol P. Linear momentum represented by the symbol P. Linear momentum represented by the symbol P. Actually, the impact of force we can study means we will learn the linear momentum. The impact of force is more. See here, the impact force is more. When the impact of force is more, the condition. When the impact of force is more means the mass of the body, the mass and velocity of the body also more. What happens? The impact of force become more. So when the impact of force is more, we are considering certain body, the mass and velocity of the body is more. The impact of the force also more. Next, the impact of the force we can determine we have to use a new quantity. We have to study a new quantity. That new quantity is called, what is that? Linear momentum. What is that? Linear momentum. So the impact of force we can determine means we need new quantity. That new quantity is called linear momentum. If you use the linear momentum, what we have to learn? We learn that impact of force, that means effect of force. Here, effect of force. So the impact of force is more when the mass and velocity of the body is also more. The mass and velocity of the object also high. We can the impact of force is more when means the mass and velocity of the body or object also high or more. So the impact of force we can determine, we have to study a new quantity is called linear momentum. So define definition of, what is the definition of linear momentum? Means the mass and the product of, what is that? See the word? The product, mass and velocity of the body gives the magnitude of, what is that? Magnitude. Magnitude means number of object or size of object or value of the object. So magnitude of the linear momentum. Magnitude of the linear momentum. Definition: the product of mass and velocity of the body or object gives the magnitude of the linear momentum. So next, this is 2 mark question. Another one, the next 1 mark question. It is a vector quantity. It is a vector quantity. I hope you knew that vector and a scalar quantity. Just I recall that scalar means the quantity has only magnitude. Vector means they have both magnitude and direction. So here linear momentum. See that I know. Linear momentum is what quantity? It is a vector quantity. Next, unit of linear momentum. Unit we can express in number of ways, but in our syllabus they are given 2 ways. One is the SI unit. SI unit of linear momentum, kilogram meter per second. Next, another unit, CGS unit. SI unit, System of International Gauss gram centigram second system. What is that means? Gram centimeter second inverse. These are the units of linear momentum. So it is what quantity? It is a vector quantity. Unit of linear momentum we can express in SI unit, kg meter per second. If we express in CGS unit, gram centimeter second inverse. Next, linear momentum represented by the symbol P equal to m into v. This is the mathematical expression of linear momentum. P equal to, that means the product of mass and velocity of the body gives the magnitude of the linear momentum. That we can express in equation. See, P is equal to what is that? mv. So what is the purpose? We want to learn linear momentum means we can study the impact of force. Means we need definitely linear momentum. Now you are understood what is linear momentum, why we want to study linear momentum, what is the use of linear momentum and definition of linear momentum. Then it is a what quantity? It is a vector quantity, units and CGS unit, SI units we have discussed. If you have any doubt for this linear momentum topic, no, I hope. So next we are going to discuss Newton first law. What is that? Newton first law. So Newton first law is also known as inertia. Just you recall that. What is inertia? The inability of the body. What is that? Inability of the body change the state by itself, or the force acting on the body, the position of the body does not change by itself is called, what is that? Inertia. We have discussed, and types of inertia we have discussed, isn't it? Today we are going to discuss what is that next topic? Newton first law. It is also inertia, and also if you use that Newton first law, we can find the definition of force. So we want to study the definition of force. Means what law we can choose? Newton first law. What is Newton first law means? The Newton first law states that the state of the state of the body is state of rest or uniform motion unless and until it compelled to change by itself by an applied unbalanced force or external unbalanced force. What is that? External unbalanced force. So see that as it is book, every body in the state of rest or uniform motion continuously, isn't it? Am I correct? For example, in our day-to-day life, we can see number of objects surrounding us. Moving objects, non-moving objects, living objects, non-living objects, isn't it? How that they are maybe continuously moving or continuously rest or time to time moving or time to time comes to rest. So Newton first law states that every body continuously, what is that? Every body continues to be. So every object or body, every body continues in the state of, every body continues to be in the state of, in its or in the state of, what is the state? We can say rest or uniform motion. The state of rest. The state is very important. What is the state? What are the state? Rest or uniform motion. How long? It will be in the number of years. We don't want to disturb. Maybe the object is continuous rest or uniform motion. For example, in your home, one chair is there. If you don't disturb, the chair does not move anywhere. How long? Without disturbing time. Suppose the fan in your home continuously running. Without switch off, the fan continuously what happened? Running when without power off also. So every body continues in the state of rest or uniform motion. Next word is important. Unless or until by an applied, what is that? By an applied what force? External, the word important, external, unbalanced, not a balanced, unbalanced force. When I underline, no, that is important words. Suppose we have to apply the external unbalanced force. What happened? For example, in your home, you can see number of moving object and non-moving object. If you see, example, one rest object, the object is rest. Next, the object continuous, what is the state? Continuous motion. These are the two conditions. So example of the object is at rest. Is at rest. The object is at continuous motion. Is at continuous motion. Example, in your day-to-day life, you are seeing number of objects. Am I correct? So, in your book, say any other examples, we can say number of examples, table, fan, wall clock, etc. These are the how that the object should be rest. Book is continuous, the state is rest. Table, the state is rest. Fan, the state is rest. Wall clock, how that it is to be rest position. And we can number of example we can put at that. See here, the object is a continuous motion. Fan running continuously. Wall clock, otherwise TV running. We can say the number of example. You can say, otherwise you refer that book. What are the moving object continuously? So these are how long it to be rest. Means these objects. Without acting on the force, the objects are without acting on external unbalanced force, these objects are rest. So without acting in these objects, these are continuously uniform motion. Suppose when applying the external unbalanced force, what is that? Now we can apply the external unbalanced force. What happened? The position of the state of the object is to be changed. These are rest object, no, it is to be moving. Here also we can apply the what we want to apply, the external unbalanced force. What happened? The running continuously, it comes to rest. The state is changed. What happened? The final conclusion, the state of object going to change. What is the reason? Due to external unbalanced force. What is the reason? The external unbalanced force, the state of object going to change. This indicates, or this is known as Newton's first law. So every body in the state of rest or uniform motion, how long means unless or until by an applied unbalanced force. If we apply, the state should be changed. How to change? The rest is converted into motion, the motion converted into rest. This is known as Newton's first law or inertia, or we have to study the Newton's first law. We can give the definition of force. What is that? Definition of force. Okay, next we are going to discuss types of forces. So next, before we are going to discuss types of force, what effect they produce on the body. So due to the force, produces or tries to produce the motion of, what is that? The motion of static body. Here static means the object without movement. They are in the rest question. So produces or try to produces, what is that? The motion of static body, the effect of force. Next, stops or tries to stop the dynamic body or moving body. What is that? Moving. So what is that? Stops or try to stop the moving body. Suppose one of the object moving continuously. If you apply the force, what happens? It comes to rest. That is known as stops or try to stop the, what is that? Moving body. Next, change or tries to change the direction. What is that? Direction of motion of body. Direction of motion of body. Direction of motion of body. What is that? Direction of motion of body. It changes the direction. When you apply the force, happen? It changes the direction, it stops the moving body, or it starts to produce a static body, motion of static body. These are the effects of force. So force is used to produce or try to produce the motion of static body, or stops or try to stops to the moving body, or change or try to change the direction of the motion of body. Direction of the motion of body. These are the force effects. Next, we are going to discuss types of forces. What is that? Types of force. What is our next topic? Types of forces. So based on the direction of force, it is classified into two types. One is balanced force. So definitely second one is, what is that? Unbalanced force. Sorry for the mistake. Parallel forces and unlike parallel forces. So like parallel forces, types of forces, like parallel force, like parallel force. Second one, unlike parallel. So based on the direction, their force or types into parallel force, unlike parallel, like parallel force, unlike parallel force. So first we are going to discuss like parallel forces. What is that? Like parallel forces. So what is like parallel forces? We can give simply the definition. So you also give the simply the definition. The two or more equal like or unlike parallel forces. What is that? Two or more forces equal or unequal magnitude acting along the same direction. What is it? Two or more forces act equal. The word is important. Equal or unequal magnitude. So two or more forces equal or unequal magnitude acting on the same direction of the body is known as like parallel forces. Like parallel forces. So for example, I will take a rectangular object, see. So two or more forces, see, this is 1, 2, 3, 4. We can represent F1, F2, F1, F2, F3, F4. So two or more forces equal or unequal. This is equal magnitude. I will show that how that unequal magnitude. Another rectangular object. So force length, the value of the force going to change. Unequal magnitude. This is equal magnitude. Equal magnitude. What is this? Unequal. Unequal magnitude. Acting on the same direction, all that towards the object, isn't it? So this type of forces are said to be like parallel forces. What is that? Like parallel forces. So next we are going to discuss second one. Unlike parallel forces. What is that? Unlike parallel forces. The same sentence we should repeat that. See how? Don't memorize. Two or more forces equal. How that means? Equal or unequal. What is that? Equal or unequal magnitude. Unequal magnitude acting on the opposite direction. Opposite direction. That is same direction, like parallel force. Opposite direction is known as, what is that? Unlike parallel forces. Unlike parallel forces. So, example, if you take that rectangular object, first equal magnitude, next unequal magnitude, equal magnitude, unequal. How that? They are acting in the opposite direction. See, the two forces are more forces. So, acting in the opposite direction. How that acting? Opposite direction. See, unequal magnitude, so this is the equal magnitude, unequal magnitude acting in the opposite direction. So based on the direction, the force are classified into like parallel force and unlike parallel force. Next, resultant force. Next topic, resultant force. This is also very easy. 2-mark question. What is our next topic? Resultant parallel forces. Resultant force. Resultant force. What is the resultant force? First I will give simple definition. See, I will take one object. This is the object. In that object, I can apply number of force. See, this is F1, F2, F3, F4, F5, F6, F7. What is the resultant means? Force is equal to, represented by capital F, equal to F1 plus F2 plus F3 plus F4 plus F5 plus F6 plus F7 by 7 is known as resultant force, or sorry for the mistake. The addition of, that means the vector sum of all the forces are represented by resultant force. If you take one object, we have to apply number of forces. All the number of forces produce one force, that is known as resultant force. All the force give the final effect is called, what is that? Resultant force. The several force acting simultaneously. What is that? The several force. See that F1, F2, F3, F4. Several force acting simultaneously on the body. The combined, what is that? The combined effect of all the forces are said to be, what is that? Resultant force. So definition of resultant force: the number of forces or several forces acting simultaneously on the body. The combined effect of all the forces are said to be resultant force. I showed that example. Next, balanced force. So one more point here. When we add all the forces, the combined effect should be vector addition or vector sum of. We have to add in the vector formation, not in the ordinary form. I'll explain the 11th standard in your coming lesson. What is the vector addition? Not available in our syllabus. So you have to note it down. The vector sum. So next, balanced force. What is that? Next, our topic is balanced force. The resultant force of all forces acting on the body. What is that? The resultant force of all the forces acting on the body. The resultant force of all the forces acting on the body is equal to 0. What is that? Is equal to 0. That means, see, I'll take one rigid object. Rigid means like iron rod. Okay, iron ball. So see here, number of forces: F1, F2, F3, F4, F5. So what is the resultant? F is equal to F1 plus F2 plus F3 plus F4 plus F5. That is equal to 0. The resultant force of all the forces. What is the resultant force? All the forces acting on the body is equal to 0. That means that when applied several forces, the object position does not change. The object position, what happened? It should not change or does not change. It's known as a balanced force. That is that, what is the result? When you apply the force, it does not produce any movement or any, does not change any state. The result, what is that? 0, no. That is known as balanced force. Next, unbalanced force. What is that? Unbalanced force. So the same sentence we have to repeat. The resultant forces of all the force acting on the body is not equal to 0. Not equal to 0. The word is important. Not equal to 0. What happened? They produces or they cause its motion. They cause its motion is known as unbalanced force. For example, I'll show. See here. I'll take a rigid object. See, forces F1, F2, F3, F4, F5. So F is equal to F1 plus F2 plus F3 plus F4 plus F5. What is that? Not equal to 0. See that? Not equal to 0. When we are applying the force, no. Due to the force, the resultant force of all the forces, they produce the cause. Produces the state of, produces the change their state. Here, what is the meaning of change their state? Maybe initially it is rest, it continues, it is converted into motion, or it is initially motion, we have to apply force, it comes to rest. What is that? Rest. Produces the change their state. Is known as unbalanced force. What is that? Unbalanced. Next, another topic, equilibrium. Before equilibrium, we have to study the equilibrium. What is that? Equilibrium. Learn that equilibrium. What is equilibrium means, sir? Is nothing but when we are applying the resultant force on the body. Resultant force F acting on the body. The body does not change the state. Called equilibrium. That means unbalanced force. For example, one ball is there. One person gives a force. F is equal to 5 Newtons. Due to the force acting on the body, the ball position should not change. Remains the same state when we applied the force. The ball position remains the same state when we apply the force also. The ball represents equilibrium position. What is that? Equilibrium position. Equilibrium means, suppose if you take the car, when you are moving in the car, okay, when you are moving in the car, which direction? In this direction. The force, that means the resultant, so the car brought into stops. So the car initially, how that means continuously moving. We have to brought into rest. That means stop the car. How to means we have to apply the force. Apply the force that is equal to the resultant force, but in opposite direction. What direction? Opposite direction. So what is equilibrium? A body brought into rest. What is that? A body brought into rest. That means the object initially how that? They are continuously moving, or they are in moving position or motion position. When we apply the force, that force is it comes to rest. This is known as equilibrium. The body, in the book they are given, the body brought into rest or equilibrium. When we apply the force, we are applied forces equal to the resultant. But how we have to apply? In opposite direction of the resultant force is known as equilibrium. Here we are taking the example. We have to move in the car. Where we are moving? In the car. When the car comes to stop, when we apply the brake, we are applied brake. No, that applied brake is nothing but equal for what? Resultant force. How that applied? In opposite direction. So that's why the car comes to rest. That means equilibrium position. This is known as equilibrium. So what we have discussed today? Linear momentum. Next, force. Types of forces. Resultant force. Balanced force. Unbalanced force. Equilibrium. If you have any doubt the following topics or the above topics, please ask me. Thank you.